Hi, I thought maybe it was time for me to do a video on how to calculate the accuracy and tolerance on meters, since that was part of Lab 1 homework assignment, and I know some have been having problems with that. So I'm going to do a video on how to do that on a digital multimeter, and then another one on how to do this calculation for accuracy and tolerance for a VOM. So let's start by looking at specifications, because I know a lot of people have trouble reading specifications, especially when you're new to the field and it's strange to you. So what I'm going to do is I'm going to launch a web browser, and what I decided is that we're going to do a fluke meter. Now I know in your homework assignment there's also a fluke meter to do, but I'm going to pick a different one, only because that way you can use it as a reference to do the one that's in your homework assignment. So I'm going to come up to the address bar, and I'm going to type in what I want here. And what I want to do is I want to look for a fluke, and I'm going to choose a 117. And you'll see that in the listings here I have the 117. It says a manual. I'm kind of tempted to do that one. The 117, 323, and so on and so forth. Oh, there's specs. But I want to go just to the straightaway 117. So let me just tap there, and the Google page loads. And I find that when you're doing anything with equipment or instruments, anything like that, it's best if you go right to the manufacturer's web page. So I'm going to scroll down here just a little bit, and you'll see that there's a whole bunch of ads here for fluke products. I don't want any of those. You might be tempted to say, well, here it is, let me go to this company. No, you don't want to go there. You want to look for the manufacturer, and the manufacturer is Fluke. So I go down to the next one, and here's Fluke. That's ENUS Fluke. That's English, United States Fluke. You look down here, there's an Amazon. I don't want that. eBay, I definitely don't want eBay. If you scroll down further here, you'll see there's Gizmoholic and Sears, and so I don't want any of those. I want the manufacturer. So I'm going to come up to the manufacturer link, and I like to work by opening pages in different tabs on my web browser. So I'm going to right click on this link, and I'm going to say open link in a new tab. I'm using Chrome. The other web browsers work in a very similar manner. And it takes me to the Fluke 117. This is an electrician's digital multimeter. And it shows me a picture of it. And I can get a pretty good idea of just from this little picture some of the functions and the digits that are available. But as in most web pages, if I'd like to see a larger picture of this, most web browsers have a zoom function. But if you right click on the image, there's usually an option in the context-specific menu to open the image, and so you could just see the image. Now I want you to note that I called this a context-specific menu. You might have heard it called a pop-up menu. And they call it context-specific because if I right-click over here, notice I get different options. So depending upon where you right-click, you get different options. So it's context specific. So I'm going to right click on this object, and I'm going to say open this in a new tab, and it opens it in another tab, and I get a larger picture of this meter. And I can clearly see that there are 3 digits, and it looks like this last digit over here is displaying a 6. So I know it's a 3-digit, and I know that it's more than 3.5. So if it was 3.5, this would only be a 1. So this must be a 3 3/4 digit meter. Fluke tends to make a lot of 3 3/4 digit meters. And if I look down here, the range switch, you'll see there's an auto volts, low Z or low impedance, and off, volts AC, volts DC, millivolts AC and DC, ohms, continuity, and so on and so forth. So I see that this has a function selector, but it doesn't really have a range selector. There's a manual ranging switch here, but all in all, when it's just a function that you're selecting, it means the meter's probably auto ranging, so that you can pretty much just put it on, okay, I'm going to measure volts DC, and no matter what you're measuring, the meter will automatically set to the best range to measure that voltage or current or whatever you're measuring. So I'm going to assume that this is an auto range meter. So let me go back to the page, and now I would like to find specifications. So I come in and scroll down, and you don't have to read everything. You can just skim through. There's information here that you really don't need for this product or this project. However, if you look here, here's specs for specifications. So I'm going to click on specifications or specs, and it starts giving me some specifications for this meter. Now, a lot of these specifications you also do not need for this project that we're working on. And as I look through here, I don't need any of this. It's okay that you don't understand that stuff. And as I look through here, it's like there's one here that makes sense to me, and that's display. Because you need to know for sure how many digits this meter can display. So this says digital, 6,000 counts, and there's an update section here, which you don't need also for this lab, but 6,000 counts, that's good to know, because that tells you the resolution of this display. So what I'm going to do is, I like taking notes. So over on my notepad here, I am going to say that we are using a Fluke 117, and the display my pen's a little screwy today, is 6,000 counts. So now I have that recorded. Now let me come back to the specification sheet, because I need accuracy numbers. So I'm going to continue scrolling down, and there's a section here called accuracy specifications. And you'll see that there are specifications for DC millivolts, for DC volts, for auto volts, for AC milliamperes, for AC volts, continuity, ohms. So all of the functions have specifications. But let's just look at the DC voltage. And let's assume we're going to be measuring 48 volts. So I look at this specifications, and it looks like it has a 600 millivolt range, and it has a resolution of 0.1 millivolts. It has a 6 volt range, a 60 volt range, and a 600 volt range, and it gives me the accuracy for these ranges. So I'm going to again go back to my pad, and remember I said I would really like to be able to read 48 volts. So I want to read 48 volts DC. So that means I'm going to be doing that on the 60 volt DC range. And the 60 volt DC range has a resolution of 0.01 volts. So on the 60 volt range, 60.00, I have a resolution of 0.01 volts. So I have a resolution here of 10 millivolts. 0.01 volts is equal to 10 millivolts. So the specifications are listed here. The accuracy is listed right here. And the accuracy is actually listed in a way that I haven't seen it before either. Plus or minus, parentheses, and then a square bracket, and it says percent of reading. So this is going to be a percent of whatever the meter happens to be reading, plus, and then another set of square brackets, counts, and then close parentheses, and then there's a colon. And then behind the colon, it tells us that it is 0.5. Let me get rid of this. So 0.5% plus 2 counts. So that's what this 0.5% plus 2 means. This is the percent of reading. This is the number of counts. Number of counts being digits. So on the 60 volt range, I'm at 0.5% plus 2 counts, or plus 2 digits. There's something important for you to remember also here, and that is the fact that this says plus or minus out here. That plus or minus, even though this says plus, also means that the digit counts are plus and minus. So we're also going to have to add and subtract 2 digits. So let's do the calculations for tolerance when measuring the 48 volts DC on the 60 volt range. So let me change pages here, and I'll come over here and we're going to measure 48 volts DC, and it's again plus or minus 0.5% plus 2. So here's how we're going to do this. So 0.5%, to calculate the percentage, we're going to take the reading that we're making, because this is in percent reading. So it's 48 volts times 0.5%. Now 0.5% is actually 0.005, because percentage is based on 100. I can rewrite this by saying 48 volts DC times 0.5 divided by 100, and this will equal my tolerance. So let's do this math. I'm going to bring up the Windows calculator to do this, and I'm going to come in here and I'm going to say 0.5 divided by 100 equals, and notice I got what I had said it was, 0.005. So we're going to have 48 volts DC times 0.005, and let's see what that equals. So let's multiply this by 48 equals 0.24. So this becomes 0.24 volts. So that means 48 volts DC is going to be plus or minus 0.24 volts. So to find my tolerance, I'll take the 48 volts DC minus the 0.24 volts, and that's going to equal something, and I'll take the 48 volts DC plus 0.24 volts equals, well, this one I can do in my head, because this is going to become 48.24, and 48 minus 0.24 is equal to 47.76, is equal to 47.76 47.76. So my tolerance is going to be 47.76 volts to 48.24 volts. But I still have to figure out the fact that I've got that plus 2 counts. So up here I still have this plus 2 counts. So how is that going to affect my overall tolerance? Let's go to another page here, and 47.76. So I have 47.76 to 48.24. So I have 2 digits. The meter's actually going to read 47.76. So this is the digit that we're talking about for the plus or minus 2 digits. You want to subtract 2 digits from this because you're looking for the worst case. So if I take the minus 2 digits, it's the same as subtracting 0.02 volts from this, which means that I end up with 47.74 volts DC as my low limit or my low end tolerance. Then I have to add 2 digits to the upper end. So I have 48.24 plus the 2 digits. Again, this is the digit that it's going to get added to. The worst case means that it's going to be higher, because this is my low limit, this is my high limit. So it's 48.26 volts DC. So my overall tolerance on this meter is 47.74 volts DC to 48.26 volts DC. So if I was reading exactly 48 volts, in other words, if my source that I was measuring is exactly 48 volts, the meter could read in this range and still be in tolerance and still be an accurate meter. So that's how you calculate tolerance when it's a percent of the reading that you're getting off the meter. So I hope that helped you. And the next video I'm going to be doing is the same type of situation, however it'll be on a VOM.